Hello everyone, welcome back to PMAC1140. So so far you've been dealing with a lot of number in matrix. We can also use the coefficient of the system of linear equation to create a matrix. However, there's another number that any matrix can be assigned to. That number we call the determinant. So in section 7.5 we'll be learning how to find the determinant of the matrix, okay, of any matrix. It could be the matrix at any dimension. We can find the determinant, okay. The purpose of the determinant is to solve the system of linear equation. So we can use a determinant to solve the system of linear equation. Okay. So last time we used echelon form and reduced echelon form to solve a system of linear equation. Today we're going to use matrix determinant to solve system of linear equation. That part I will put it at the end of the lecture. There's another way to solve system of linear equation, which is in section 7.6. In this section we just focus on how to find determinant and use determinant to solve the system of linear equation only for any matrix you want, and we have a general rules to find the determinant of any matrix. So let's get started. Okay, section 7.5 determinant and Kramer rules. I don't have enough time to look it up. This name, I believe this is the name of a mathematician, a German guy, but if you have time, please look it up. This name is try to get some information about it. It's just when we learn math, we try to get something fun also, right? So I mean, I think he will have something very interesting for you to read. So I mean, if you want to do more research on Kramer rules, look it up, this name. Okay. Alright, so the determinant is a number assigned to each matrix, and we have the notion for determinant it look like the absolute bar. It look like absolute bar. So if you have absolute, I'm not going to say absolute because it's not absolute, but it look like absolute bar. It look like absolute bar. It has this notion. Absolute determinant of A, and this is the notation for the determinant. So this is determinant of a matrix A, okay, determinant of matrix A. It's not absolute, okay, because when you find a determinant, it could be negative, okay. So this is not absolute, and we can find, as I said, we can find determinant of any matrix, but it must be the square matrix, okay. It must be the square matrix. It means what? It means that the number of columns and the number of rows must be the same in order to find determinant. If it is not square matrix, then we cannot find a determinant, okay. So in order to find determinant of a matrix, that matrix must be a square matrix. Must be a square matrix. Must be a square matrix. Okay. For example, we have matrix 2 by 2, 2 by 3, n by n. Okay, 5 by 5. Okay, we can find the determinant easily. For the matrix 2 by 2, it's very easy to find the determinant. Okay, but 3 by 3, 4 by 4 is kind of harder. But if you follow the certain rules, I will show you the rule right now to find determinant of any matrix. Then, and you do work on the process carefully, then I'm sure that anyone can find a determinant. Of course, you can use the calculator to find a determinant, but on the test you have to show work. Okay, so let me jump straight to the example, and on this first example I will show you how to find a determinant of matrix 2 by 2. So let's name this matrix a matrix A. Okay, and this matrix A has the entry is 6 minus 3, 2, 3. So in order to find the determinant of this matrix, all you have to do is you just multiply you multiply diagonally between two entry, and you subtract from each other. Okay, so the rule is, if you have matrix A with entry A, B, C, D, then you can find determinant of matrix A is A times D minus B times C. Okay, the order is very important. Okay, so you have to start with A times D first, then minus B times C. You don't want to start B times C first. Okay, that would be wrong. So this is the rule. Okay, so I'm gonna box them. This is the rule for 2 by 2 matrix. Then if you apply this rule, then I can find the determinant of matrix A easily, right? Then the determinant of matrix A will be what? Will be 6 times 3 minus 2 times negative 3, right? So 6 times 3 is 18. You calculate them out. You 6, right? So the determinant will be 24. Okay. So the determinant over here is positive, but it doesn't mean that it doesn't mean that our determinant is always positive, because it's not absolute. Okay, it looks like absolute, but it's not absolute. Okay, it could be negative. Okay, so that is the rule in order to find the determinant of matrix 2 by 2. Okay, so that's the first example. Okay, on the second example, I will help you to find the determinant of matrix 3 by 3. Again, I'm gonna name this matrix A, and this matrix A has 2, 3, negative 1, 0, 2, 4, negative 2, 5, 6. And you see that this matrix is 2 by 3, so it is a square matrix also. Excuse me. Okay. So what is the rule? I want you to memorize this. I want to make it simple for you. So I want you to know that the side of each entry over here, I mean the side we assign for each entry over here will be like this. Okay, and those signs will be used to find determinant. So on the first row and the first column, you always start positive, negative, positive. So it's changed alternatively. Okay, same thing, but because it's positive, so this one must be negative, then this positive, then will be positive, because negative, positive, negative, positive, negative, positive. Okay, how come I can come up with those signs? Of course, this is a rule, but right now at this moment, I want you to take it for granted like that. Then, based on example 2, we can come up with rules, and that rule will work for 4x4 matrix, 5x5 matrix, and n/n matrix. Okay, so you always want to start with positive, negative, positive, alternatively changing like that. Okay. Okay, we're not gonna find positive, positive, negative, no, but always start with positive. Okay, so I circle always start with, we won't start with negative. Okay, all right. Then, so after you write down your sign already, okay, this is what you're gonna do. I want you to take, especially when you're dealing with 3x3, I want you to use the first columns. Okay, I want you to use the first column and the first row to find determinant of 3x3. So use first row and first column. Okay. Okay. You mean maybe some of you ask you why we have to use the first row and the first row? Okay, we use the first row and the second column and third column and the first row, something like that? Yes, we can. We can. We can use any column, any row. Okay. However, it depends on the entry, because the way you use, the way you pick a column and the row, it depends on how you want to make your matrix simpler, so that you can find the determinant easier. Because the way you pick row and columns to find determinant, okay, it will help you find certain matrix faster, find the determinant of certain matrix faster. Okay, if you pick it wisely, you probably spend only 1 minute to find the determinant. If not, you probably have to spend 10 minutes to find determinant. Okay, so it's up to you. It's up to you if you want to pick a certain row or certain column to find matrix, to find determinant of the matrix. But if you use first row and the first column, of course it's always work. Okay, but sometime if you use first row and the first column, it will take more time, as I already said. However, it's working all the time. Okay, it always. Actually, in my opinion, every time I use the 3x3 or 4x4, 5x5, I always use first column, first row. I mean, if you pick wisely, then it's faster. But I mean, some of students, some of you guys, I'm sorry for saying this, but you guys lazy to memorize the rule. Then just go ahead, pick the first column and the first row. Okay. And what if on the test and you get panic? Okay, you forgot all the rules. Then just pick the first row and first column, or you want to go fast and you don't want to think too much about which way or and how I pick wisely, how wisely I should pick to get it simpler, and you jump straight to the problem. Just go ahead and pick the first column and the first row. Okay. So right now I'm going to show you the first row and the first column, first row and the first column first. Then on the next few examples, then I'll show you how to pick wisely. Okay, because we need to come up with the formula first, the rule first, the general rules to find the determinant for n/n matrix. Okay. Okay. I think I'm talking too much, but let's jump straight to this example right now. So after I assign all the sign for each entry of the matrix, okay, and I pick the first row and the first column. So I pick the first row and the first column. So I'm gonna just go ahead cross that out. So I'm gonna you can cross that out. Okay, you just go ahead cross that out. And what you after you cross out, what you have left is 2, 4, 5, and 6. Okay, 2, 4, 5, and 6. That is the first row and the first column. Okay. Alright. Then I can write the determinant of matrix A equal. Okay. Equal what? Equal 2. 2. Why we have to pick 2? Because I already picked the first column and the first row. So this is it's like the way I cross. You see the intersection. So I'm going to pick the first one. Okay, I pick 2. Okay, positive. Multiply by determinant of the matrix 2 by 2 right here. So it will be 2, 4, 5, 6. Okay. Then what? Then you jump to negative. Right? Then you jump to negative. Okay. You jump to negative. So it could be negative what? Negative 3. Okay. Okay. Then you jump to this one, right? You jump to this one. It means that you, instead of crossing the first row and the first column, you're gonna cross the first row and the second column. Right? So what you have left is 0, 4, negative 2, 6. Okay. Then you jump to the last entry of the first row. Okay. There will be positive, right? Because we already assigned positive. Positive what? Positive of negative 1, right? Okay. Positive negative 1. Okay. Time. Then the first row and the last column. So you have left is 0, 2, negative 2, 5. I mean, you see that I always pick the first row and the first column first, right? Then you go to the first row and the second column, the first row and the third column. That's how you do it. Okay, that's how you do it. Okay, I mean, you can do like this. You pick the first row and the first column, then you go instead going horizontally, you're going vertically. So you can do 2. First row, first column, then you have this matrix, then you have minus 0. You see that? Minus 0 will give you this and this. Then plus, then plus minus 2 give you first row and the last first column, last row, right? You can go. So it could be first column and the last row. You can start like that too. Okay. Yes. Alright. So after I got this, okay, then what? Then we can find the determinant easily of the 2 by 2. So it will be 2. 2 times 2 is 6. 2 times 6, right? Minus 5 times 4, right? Okay. Minus 3, 0 times 6, right? Minus negative 2 times 4, right? Then minus 1, 0 times 5 minus negative 2 times 2. Okay. Alright. Then you can go ahead and calculate them out. So give you 12 minus, going to give negative 8, and give you, this is negative positive 8, so negative 24, right? I give you negative 4, so positive negative 4, right? So negative 16 minus 24 minus 4, which is give you negative 44. So the determinant of matrix A is negative 44. Okay, good. Now let's use the result and the process we just finished to create general rules for any matrix n by n. Let's see if we can come up with that or not. Okay. Okay. So you see that you have 3 terms here. Okay, and each term here they have a specific name for that. Okay, so each term here we have a name. We call that this is here, here, and here. All of them we call that cofactor. Okay, so we have 3 cofactor. Okay, 3 cofactor. Okay, of course not include the sign, not include the sign, the original one only. Okay, the original one only. So over here the cofactor will be from here to here. Okay, so the cofactor is that this part, and the cofactor here is this. Okay, not the plus. Okay, not the plus sign. Okay, not over here, not the negative sign, and over here not the plus sign. Okay, and the value, those value here, the value that the entries attached to the sign attached to, sorry, those value here. Okay, those value, the sign right here. Okay, okay. We have also have a name for that. I mean, we don't have a name for that, but this value, this sign right here, there's a rules. There's a general rule. We're gonna come up with the general rule to get the sign. But what I mean over here is this one. I'm sorry. This we call that minor. So we have 3 minor and 3 cofactor. Okay. So you see the way we can come up with 3 minor and 3 cofactor here is based on, okay, so you see that this is over here we pick this, so 2, 4, 5, 6, so we're going to delist the first row and the first column, right? So, okay, so and we have a general rules for in order to come up with this, and because we have general rule to come up with this, so we have a notion for cofactor and minor. Okay, for minor, okay, we're gonna choose this notion Mij. Okay, and for cofactor we use the notion Aij. Okay, for Mij and Aj. Of course, with I and J is from in this case is from 1 to 3, right? In this case from 1 to 3, so it could I and J is from 1 to n. It could be anything. Okay, when we're dealing with because we're trying to come up with the general rules for n by n. Okay. Okay, how about the sign? How about the sign right here? The sign we can come up with right here. The sign attached to each entry. Okay. The reason you can come up with the sign is that it also belong to Aij. It belongs. It depends on how you pick wisely. Okay, so the general rules will be Aij equal to -1 raised to I plus j times Mij. I mean, some students read this and it's kind of very confusing, right? I mean, that's what I said at the beginning. You know, you just go ahead, do it without knowing this. But it's good if you know it, because maybe on homework, my MATLAB homework, they ask you to find the minor or the cofactor only. Then you know that which one they ask you to find. Okay, so you see right here, the cofactor is the whole thing. See, the cofactor is the whole thing. The reason you can come up with positive 2, the reason you can come up with positive, because of this, because the part -1 raised to I plus j. So ij is what? Ij is easy to do. This is the first column and the first row, the first column, so I is row. Okay, I is row, so this is row, so this column. So first row, first column, so first row, first column should be 1 plus 1, right? Because first one. Okay, 1 plus 1, 1 plus 1 to -1 raised to second power, so we be positive. Okay, what is MIJ? MIJ we got this minor, right? So MIJ, because we pick the first row, first column, so this minor right here, we call it what? This minor right here is this minor over here will be what? Will be going to be M11. Right, so be M11 right here. Okay, and over here will be what? The first column, second, first row, and the second row will be M12. This is M12. Okay, so over here will be M11. Okay, that's the minor. So this is minor over here will be M12, because the first row, second column, and over here what? First row in order to get it. So first row and third column. So this minor over here will be what? It could be M13. Okay. All right. If you pick another one, if you pick the first, if you try to find the determinant by using the first row, first column and third row, there will be what? Will be M33, right? If you take this, you delete this row and this row, the last row, the last column, there will be M33. Okay, so on the homework, they may ask you to find certain minor, M33, M22, M11, M23, M23 mean you delete M23, mean you delete the second row and the last column. Okay, then this you will have then you have the minor. Okay, everybody clear? So because of this. Okay, all right, and AHG is the whole thing. AHG is the whole thing. All right, very easy. It's not really that hard. Okay. So if they ask you to find, for example, cofactor A11 or A112, for example, which one is A12? I mean A12 will be what? A12 will be a -1, 1 plus 2, right? Time M, example, time M12. M12 is M12 will be first row, second column. So M12 will be 0, -2, 4, 6. See, 0, 0, 4, -2, 6. That's it. M12. Okay, but the sign will be -1, -1 plus 2, 3, so it will be negative. Okay, so when you calculate a cofactor, okay, AIG, then you don't include the entry. So I don't think I should. I mean, when I draw like this, so this not. I mean, the cofactor does not include the entry. Okay, it does not include. It include the sign. That's what I mean when I covered it. It include the sign and the the minor only. And the sign that include the sign the sign attached to each entry and the minor only. So I mean, you see that it's kind of confusing when you do when you try to understand the general rules right here, right? But the reason I have to talk about it because whatever on the homework they just ask you to find A11, M1, A12 or M12 or A23, something like that. Then you know which one you should do. Okay, so remember the cofactor does not include the entry. Okay, but when you calculate the determinant, you have to include it. Okay, so I think when I cover like this also, I kind of not really mess up, but I know what I mean. But I mean it's hard to put over here because when I calculate everything, I write out everything. But just remember that the cofactor does not include. So this does not, the cofactor does not include 3. It does not include 2, 3, and -1. Okay, does not include 2, 3, and -1. All right, but I cannot put parentheses anywhere because I mean I don't think I should put parentheses. But I mean if I put a parenthesis like that, then it means I don't include the negative. I don't include the positive. You know, so I mean it's kind of hard. But I mean I just want to remind you that it does not include the entry. Okay, all right. So that is the way you have to find determinant for any matrix. Okay, then how about we can come up with the general rules to find the determinant of the square of n by n matrix. How we do that? Because I say that we always use the first row and the first column, so I think that's easy to start like that. Then for n by n matrix, then how we do that? For n by n matrix, so this determinant. So let's write out the n by n matrix first. So this is to be A11, right? And then over here we go A12, and this is A1n. Then this is this is A21. This is AN1, and finally we have ANN here. And this is a N2, something like that. So this is n by n matrix. Okay, this is n by n matrix. Now, in order to find the determinant, okay, because I always say we will start with the first row and the first column. And the first row and the first column will be what? A11, right? First row, first column. First row, first column will be A11. Then whatever you have here will be the cofactor, A11. Because you delete this, okay? You delete first column, first row, first column. So what you have left is this, right? What you have left is this. This is the minor right here in order to get it, okay? And the whole thing A11 will be the minor, and this the negative one raised to I plus j. Okay, so over here will be so first row, second column, so A12 plus A1n, A1n. Okay, so this is determinant. This formula over here, this general rule to find the determinant of n by n matrix, but using the first row, and start with the first column. Okay, so I think I'm going to use the first row and start with first column. First start. So I'm going to put over here a little bit, just to make it clear. So use the first row and start with first column. So use the first row and start with first column. Then we use the first row, second column. Use the first row, third column. Okay, so that's what we come up with this. But it's not always we should come up. It's not always that we should start with the first row and we start with the first column. It's not always like that. Okay. For example, the same for the same matrix. The same matrix. The same matrix A we have before is 2, 3, -1, 0, 2, 4, -2, 5, 6. You see that last time that we have to use first row and we start with first column, second column, third column. So you see that we have three terms. But look at that. If we start with first column, okay, we start first column, first row, then first column, let me see, then first column, second row. Let's see, because we have, look at that, we have 0 right here. Okay, if we have 0 right here, it means what? It means that if we use this row as the start, okay, then we start with second row instead of starting with the first row. We start second row, then the first column, second row, second column, and the second row, and the last column will be better. It will be better. Look at that. So look at that. So we start with so I'm gonna use second row. Okay, start with first column. So last time we did what? Well, last time we did use first row and the first column. Okay, right now we use second row and start with the first column. So second row and the first column. So let's put the sign first. So positive, negative, positive, negative, positive, positive, negative, negative, positive. Okay, so it'll be what? So determinant of A. Use second row and start with first column, right? Second row. See, second row and start with first column. First column. So what will you have left is what? Will be a negative 0, right? Second row, start with first column. So what you have left is 3, -1, 5, 6. Right? Then second row. Use second row, right? So we start with positive 2, right? Positive 2. Second row, second column, right? So we had 2, -1, -2, 6, right? I don't want to draw this vertical horizontal line, it might mess up. Then 4, -4, right? Because we have -4. First, second row, third columns will be 2, 3, -0. So you see that last time we had to evaluate all 3 cofactors. This is 0, so we just need to evaluate this. So you have 2, so you have 2 times 6 minus -2 times -1. So -4, 2 times 5 times -2 times 3. Okay. Then what we have? Then we have 2 will be 12, negative, positive, right? Now plus and negative, -2, right? Okay. So and this is give you 4, give you 10, right? Give you positive 6, right? Okay. So give you 20, right? Minus 40 times 16 is 64. So the answer also give you -4. See that? Same answer. But you see that if we pick wisely, you see, instead of having 3 cofactor, we have only we just need to evaluate 2 cofactor. Okay. All right. So I say again, it depends on how you pick wisely, what row and what column you pick. Then it will simplify your matrix, simplify the determinant. Okay. Now I'm going to give you another example, but now it's on. So this is example 2, and this is example 3. So I'm going to give you example 4, and we try to learn how to find a determinant of 4 by 4. Let's see if it is easier or harder, or we have to use the general rule, or you just follow my rules. You know, the general rule, as I said, the general rule is just in case when you deal with when they ask you to find a certain cofactor, certain minor, then it could be easy. But in order to find determinant, you just follow the way I assign the sign right here. Okay. For example, I have you to find determinant of matrix A. And matrix A here is 4 by 4. So you have 1, 2, 4, 0, 4. You have 0, 0, 0, 3. You have 5, 6, 2, 6, and you have 2, 4, 0, 9. Okay. Okay. Alright, so you see that this is 4 by 4. Of course, we can find the determinant. Another thing you notice is you said we have 3, 0 right here. It looked like that I should pick the second row to start with. Use the second row and start with first column, second column, third column, and fourth column, something like that. Okay. We're gonna assign the sign, so it'll be positive, negative, positive, negative, negative, positive, negative, positive, negative. So it's alternatively changing, positive, negative, positive, negative, positive. Okay. So we're gonna use second row because we have 3, 0 over here. It's easy to get rid of. Okay, use second row. Start. Okay, start with first column. Okay, then the determinant will be what? Will be A. So second row start with the first column. So the entry is 0, right? Actually negative 0, and you have 2, 0, 4, 6, 2, 6, 4, 0, 9, right? This is M21. Okay, then we have positive 0, second row, second column. So you have second row, second column. So you cross them out. So we have the 1, 0, 4, 5, 6, 6, 2, 4, 9, 2, 0, 9, 5, 2, 6. I'm sorry, it's 5, 2, 6. Okay, so then negative 0. I mean, you see that everything over here is 0. Right? I just want to write them out. So it's a second row, third column, second row, third column. So you 1, 2, 4, 5, 6, 6, right? Second row, third column, 2, 4, 9. Okay. Now second row, last column. So it will be positive 3. Second row, last column. So 1, 2, 0, 5, 6, 2, 2, 4, 0. There you go. So all of this turn out to be 0. We just go ahead and throw away. So what you have left is just 3, 1 2 0 5 6 2 2 4 0. Okay. All right. Problem is we can have a determinant 3 by 3 right here. So in order to find the determinant 3 by 3 right here, all right. Again, the concept we already finished right here in example number 3, right? So I'm gonna pick wisely. Again, I'm gonna pick wisely. So you have 2 0 right here. To think about that. If I pick let aside the sign first. So you have positive, negative, positive, negative, positive, negative, positive, negative, positive. So you see in 4 by 4 we have 3 by 3 determinant. Okay. So if you do 5 by 5 determinant, you have to deal with finding 4 by 4 determinant, and so on. You have to deal with 3 by 3 determinant. Okay. All right. So what I'm gonna pick over here to find determinant of this 3 by 3. So I'm gonna use first. I'm gonna use last column, third column. Okay, I'm going to use last column. Okay, so use, because I have 2 0 right here in the column, so use third column and start with, okay, start with first row. Okay, you see, you can use anything and start with anything. Okay. All right. So how we do that? Okay. So you have. Let me read. Okay, that's okay. We don't have to read right. Okay. So use the third column. So use this column, right? So it means that use this column means use the entry of the column. Use the entry of the column. So you have what? And start with the first row. So this row, third column, this row, third column. So use the entry because I use the third column. Okay, so I should be 0. Okay, positive 0. Okay, then you have 5 6 2 4, right? Then negative 2. Second row, third column, third column, second row. So we have 1 2 2 4. Then positive 0. Okay, 1 2 5 6. So this and this 0 already. So all you have to do with negative 2. Okay, but don't forget you still have number 3 right here. Okay, so number 3 in the front. So I forgot number 3. So number 3 should cover the whole thing. So you have this 0 0. So you have 3 times negative 2. 1 2 2 4, right? Okay, that'll give you negative 6. So this is give you 1 times 4 minus 2 times 2 times 2. So what is 0? So everything turned out to be 0. All right. So that's the way you deal with 4 by 4. Okay. Okay. So you see that in this example, if we have the matrix and that matrix contain a lot of 0, you know, the more 0 it contain in the matrix, it'd be easier for you to find determinant. Okay, by picking the row wisely, you can find. It doesn't take too much time to find determinant. But the problem is that some matrix doesn't have any 0. Okay, then of course it could be harder, right, to find the determinant. It will take you more time to find determinant for that matrix. So So if it doesn't have any zero, what we're gonna do? So if it doesn't have any zero and you want to find the determinant of that matrix, the only way to simplify the problem is that we're gonna use the elementary row operation, okay, to convert the original matrix, the one that you don't have any zero, to the new matrix that contain some zero or contain as many zero as you can. Then you calculate the determinant of that new matrix after you convert it using a row elementary operation. Then the determinant of the new matrix and the determinant of the original matrix will be the same. Okay, so in order to simplify the problem, you just use elementary row operation to convert the original matrix to the matrix that contain more zero. Okay, all right, let's go to the example number 5 right here. Let's go to the example. In this example, I have a matrix 4x4, and this matrix doesn't have any zero. Of course, you just go if you go ahead and leave it like this, and you calculate the determinant, finally you will get a determinant, but it takes a lot of time. Okay, it will take a lot of time. Alright, it takes a lot of time. So what you have to do is we're going to apply the elementary row operation on this matrix, okay, so that we have some zeros in this matrix and it's easier for you to find the determinant. Okay, so let me see. If I look at the matrix right here and I see that 2, 3, which one I can convert to, which one, what row and what column of operation of the matrix, so that we can apply the operation. Alright, so you see that 8 times 3 44, 2 times 3 6, right? 3 times 4 12. Look like that I can convert this row. So if I convert this row, so as R3, if you subtract by 3 R1, then give you R3, right? Then my new matrix will be what? This I keep it, and this I keep it. Okay, 2 2 2 negative 1. Okay. Okay, so R3 minus 3 going to be 3, so we 0, right? So 0, negative 2 times negative 3 right here. So R3 1 minus 1 is going to be 3, right? You see that? 3 3 3. So R3 1. So we 4. I'm sorry, we 4, right? And this is 3 and negative 21, so we're going to positive 12. So we 0. Look at that. This row we have 3 0. Then we can find a matrix. We can find the determinant of this matrix using the third row. Okay, so use third row, start with first column. Then determinant of A will be what? Third row start with first column, so we have 0, right? Oh, of course, I forgot a sign. So it will be positive, negative, positive, negative, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay. Then we have 0, first row, third row, first column. So you have positive zeros. You have this. So you have 2, negative 1, negative 4, 5, negative 3, 11, right? 2, 2, negative 1. There you go. There you have what? You have negative 0, right? Third row, second column, so you have 8, negative 1, negative 4, 3, negative 3, 11, 2, 2, 2, negative 1, right? Then you have positive 4, right? Then this row, third column, so you have 8, 2, negative 4, 3, 5, 11, right? 2, and you have 0, positive, negative 0, right? Actually, well, actually, you don't have to write this, but I mean, if you're good enough, you just go ahead, start from here, and jump to here, you know. Then you have what you have: 8, 2, negative 1, 3, 5, negative 3, 2, 2, 2, right? And you see that all of this 0 already, so all you have is 4, 8, 2, negative 4, 3, 5, 11, 2, 2, negative 1, right? Right? You see that? And now what? I just successfully convert, you know, a very complicated matrix without 0. Now I convert to the one that's 0, that contain more 0, and because of that, I can find the determinant faster. Alright, so right now my determinant is 3 by 3. Okay, my determinant is 3 by 3. Okay, now I just go ahead calculate this determinant. Okay, or maybe some of you is really good and some of you want to do row operation again. Okay, you're gonna do row operation again on this matrix, on this determinant. So let's do row operation again. Apply row operation again to have 0. To have 0. Okay, because right now this determinant doesn't have any 0. So let's do it again to have 0. So what we do? Let me check one more time if I make sure that I don't have any calendar mistake. Okay. Row operation again, or let me see, or maybe column operation. Oh, it doesn't matter. I mean, you can do column operation too. Okay, so look at that. Let's do column operation. It's easy. I think it'll give you 2 0, because if you do row operation, it give you only 1 0. So look at that. If I can do column 1, so column 1 right here, you add to column 3, right? Then give you column 1, the new column 1. So my new determinant will be what? Will be 4. 2 times negative 4, so we 0. You see that? Column 2, you don't do anything, so you keep it to 5 2. So negative 4, 11, negative 1 over here, still keep it. So 2 times is 20, 22 plus 2, 25, right? 2 times negative 2, 2 plus 2, 0. See that? So right have this column right here. Okay, they have 2 0. Then we're gonna use first column. Okay, then start with first row. Okay, first column and start with first row. Okay, use first column entry, that's what I mean. Okay, so use first column entry. I think I'm gonna put over here entry. So I'm gonna use third column entry. When I say use third column, second one, we mean use the entry. So use first column entry. You're gonna have, so you have positive, negative, positive, right? So you have could be 4, right? This number 4 will be on this outside, so I'll open bracket. So then you have this, so you have 0, positive 0, 5, 11, 2, negative 1, negative 25, first column, second row, so negative 25, 2, negative 4, 2, negative 1, right? Then positive 0, 2, negative 4, 5, 11. This one gone, so all you have is 4 times negative 25 times 2, 4, 2, negative 1. Right? And now this is the 2 by 2 is very easy. So this give you the 100. 2 times -1 minus 8, right? So give you -100, -2, -8, -10. So give you let me say anything. -8, -2, negative minus, oh, this is negative form, I'm sorry. So give you positive 8. So give you -600 as the determinant. Okay. All right. So what you learn from this example is that you can do the column operation, you know, the same method as the row operation to have 0 on the column. Okay. Or you can do a row operation again on the 3 by 3 matrix for the 3 by 3 determinant right here to make it simpler. If you don't want it, you just go ahead, calculate the determinant here, and give you the answer. It takes more time. Okay. All right. Okay. So on the second part of this lecture, I want to talk about Cramer rule, and this rule is used to solve the system of linear equation. So second Roman, Cramer rule. You already know that the coefficient of the system of linear equation, we can use those coefficients to set up a matrix equation, right? And we're going to create a matrix, and from that matrix, if we can find the determinant of that matrix, then it may help you to solve the system of linear equation. But how we're gonna do it? What is the Cramer rule? First of all, let's take a look at the system of 2 by 2. I mean 2 variable x and y only. We're going to try to set up the determinant of the matrix based on the coefficient of this 2 by 2 or 2 variable system of linear equation. The general one for n variable, and I'll give you example on the on 3 variable. Okay. Then if you have time, then you can solve any system of linear equation with n variable you want. I mean 5th variable, 5 variable, 6 variable, as many as you want. Okay. So let's take a look at this system first. So we have system of 2 variable. 2x plus 6y equal -1, and x plus 8y equal 2. Okay. So so this is a system of 2 variable, and we have coefficient. All this coefficient here, we can set up the matrix, and from that we can set up we can find a determinant. Okay, so let me call D as the first matrix with all the coefficient 2, 6, 1, 8. Okay. Then dx, excuse me, is the matrix that you replace the vertical one matrix right here. Okay, the column matrix right here, you replace for the first column of the D matrix, so dx will be -1, 2, 6, 8. Okay. And similarly, you can find dy by dy matrix is by replacing the last column here with the column matrix here. So it could be 2, 1, -1 and 2. Okay. So after you find dx and dy, then you can find variable x, you can find x by set up the ratio between the determinant of dx over d and the y is by set up the ratio between dy, determinant of matrix dy, over determinant of d, matrix d. You know, and when you find a determinant, it gives you the number, right? And you see that the number over the number, then it gives you variable x easily. So let's find dx. Minus 6 times 1, right? Over, I'm sorry, dx is -1 times 8. So -1 times 8 minus 6 times 2, I'm sorry. And dy is 2 times 8 minus 6 times 1. So that is x. Y is dy 2 times 2 is 4 minus -1 times 1, right? Over d is 2 times 8 minus 6 times 1. So I'll give you -8 minus 12 over 16 minus 6, right? And this is give you 5 over 16 minus 6. So I'll give you -20 over 10, right? And this is give you 5 over 10, which is give you -2 and 1.5. So you see that I can find x and y easily. I can find x and y easily of this system by finding the determinant of matrix D, dx, and dy. Now if you have 3 variables, what you gonna do? You're gonna find d, dx, dy, and dz, right? You're gonna do the same. So that is excuse me, that is the system of 2 variables. Let's jump to second example when we deal with system of 3 variables. What if I have system like this? 2x minus 3y plus 4z equal 1, x plus 6z equal 0, 3x minus 2y equal 5. Then the matrix D will be what? Matrix D will be all the coefficient will be 2, -3, 4, 1, 0, 6, 3, -2, 0, right? Then dx will be you replace the first column with the column matrix, so it will be 1, 0, 5, -3, 0, -2, 4, 6, 0, right? So that's dx. And dy will be replace the second column with the column matrix, so it will be 2, 1, 3, 1, 0, 5, 4, 6, 0. Okay, and dz will be equal to dz matrix. You replace the last column with the column matrix, 2, 1, 3, -3, 0, -2, 1, 0, 5. Right. Then similar to example number 2, we can find x by set up the determinant dx over d. So y will be determinant of dy matrix over matrix d, and z will be determinant of dz matrix over d. Okay, the determinant of dx, of d, of dz, of y we can find easily. So this is easy because you have 2 0 right here. You can use the same method. I already show you in when we learn finding determinant for 3 by 3 matrix. And then after I found the determinant, then I can set up. So the determinant of dx, is the -78. So I'm skipping those steps. Of dA is -38, and for determinant of dy, for determinant here will be negative 22 over negative 38, and dz, determinant dz will be 13 over negative 38. So I skip the step. So finding the determinant, I assume that you guys already know how to do it in part 1 of the lecture, and that's why it gives you 78 over 38. Okay, and y over here will be 11 over 19, and z will be negative 13 over 38. Okay, so you see that you can find x, y, z easily, okay, by finding the x, dy, dz. Then now what if I have n variable? You know, for the n variable, it means that I can create the matrix equation, right? With all the matrix equation with all the coefficient of x, y, z into n variable, right? Then I can have something like this. So for n variable system, we can create the matrix equation by a11, a12, a1n, right? Then a21, then an1 here, and we have ann here. Of course, because we have n variable, then I cannot use I cannot use I cannot use x, y, z, t, w, because we have only 24 letters. So I'm going to use x1, x2, xn for the variable. And over here we have a column matrix, so I'm going to use just b1, b2, and bn. Okay. Then the Kramer rule, the generic one, will be b2, x1 is dx1 over d, right? And x2 will be dx2 over d, and will be dxn over d. So that is Cramer rule. Okay. The Cramer rule is very easy. You can solve any system easily with Cramer rule. What if you can vector of matrix D turn out to be 0? Then of course, I should put the determinant notation here. So this determinant. What if matrix D that has the determinant 0? Then you cannot divide by 0. Then you see that you cannot solve for x1, x2. You cannot solve for x1. Okay, but then you might or may not can solve for x2 anyway. Okay. Oh, you cannot solve for x2 either, because if d is 0, so over here 0, you cannot divide by 0, so there's no solution in that case. I'm sorry. Okay. So if d, the determinant of d is 0, then it doesn't work, and you don't have any solution. Okay. So that is how you use Cramer to solve the system. The system of linear equation with n variable or any variable you want. Okay. On the test, of course, I'm not going to give you like 6 variable, but I might give you 4 variable: x, y, z, and w. X, y, z, and w. Okay. Or 5 variable system of linear equation. I can do that. Okay. So I think I will finish this lecture right over here. Next time on a new section, we'll be learning how to solve system by using the inverse matrix. So we will learn how to find inverse of the matrix. Okay. Please go ahead. If you don't understand anything, we'll watch the example again. Go through all of this one more time. Then if you don't get it, please send me a message to ask question. I don't mind send you back the reply as soon as I can. Okay, I'll see you next time on the next video. Bye bye.